So Alex, welcome to
Thank you very
Ekoparty.
much.
It's your first time in Argentina?
Yeah, first time in Argentina.
First time in Ekoparty, I guess,
Yes.
too.
That's right.
So what can you tell us in this time that you have been around here?
But the country,
The people, the
the
place,
people,
the
it's
city.
been very beautiful, very nice. I brought my daughter and wife with me because we wanted to kind of see it all together, especially it's the first time going to a new country. So yeah, great food and very nice people. I'm sure you get that a lot. So we've had the pizza and the ice cream and the
Yeah.
steak, of course.
Yes, like
And the whole-
we have pretty various types of food here. It's
Yep.
not just a specific one. So about the Ekoparty and the people here.
Yeah, the conference is, I don't like big commercial conferences like, the Black Hat style. So it's nice to see a lot of local people flying from everywhere here, and kind of the vibe is very nice. You can see it's about research, it's about hacking, it's about security. It's not about like, the latest cyber incidents, CISO, blah, blah, blah. So talks have been excellent as well. So good
Have you
researchers.
been able to see the other talks?
Yeah, I've seen a few today. I've been working on my slides a little bit late, but got a chance to see a few today. I was watching Nicolas's talk, which is going on right now.
Yeah.
And then tomorrow I'll have a lot more free time. So
Yeah, I think the
forward to
thing
it.
with the slides is pretty common.
yeah.
I guess that nobody finishes before their talks.
Yeah, and oftentimes you realize things at the last minute, or there's a patch at the last minute that changes everything. So you want to make sure that everything is kind of good to go.
So tell us about your talk.
Sure. So my talk is about a digital rights management feature that was added in the Windows kernel about a year ago. And it handles things like anti-video piracy and things like that. And it can run in the browser. The problem now is that the browser is very sandboxed. And what digital rights management components usually do, they do things like unpacking and binary obfuscation and encryption, decryption. They do very shady things that usually don't work well inside of the sandbox. So they kind of had to add a component in the kernel to help make that work anyway. And that obviously opened up ways for non-DRM components to abuse that mechanism and to bypass some of the sandbox mitigations that they put into place.
You said that this was fixed and then it wasn't fixed again, and now there's a new patch to fix this.
So basically, when arbitrary code guard, the mitigation, first shipped in Windows 10, it did not support digital rights management protection. So in the first release, this bug wasn't there, but because of that, the web browser was not sandboxed fully. In the new version, then they sandboxed it fully, but then they had to create this component to work inside a sandbox environment. And then by creating this component, they added this accidental backdoor, which now in the new version, they fixed that component to make it work again. So yeah, it's really kind of an evolution of security versus DRM going back and forth.
You think that this was used as an attack to victims?
I don't think this was used as an attack because of the complexity of kind of getting into the kernel, understanding its functions. Probably why they didn't patch it instead of just waiting for a new release. But definitely now that the presentation is out, there's still kind of a window now until the new version comes out in, I think, end of October, where theoretically someone could use this to bypass that mitigation. But given that the mitigation only applies on 64-bit and Edge, and you have to have a brand new video card, pretty specific for an attacker to be mitigated by this and then to want to escape out of that. So in the grand scheme of things, I don't think it makes a big difference right now, but obviously as the mitigation grows in more applications, if this had not been fixed, in 2 years, that might have been a lot worse.
So what are you working on? Where do you work?
Sure. So I work at CrowdStrike, a cybersecurity company in the U.S. now for about almost 6 years. I'm sure you've heard about them. The election with Donald Trump and the Russian hacking, and we're some of the companies that found that there was potential meddling there, and we do a lot of work with both a product that we create to secure companies as well as kind of services in IR. So I started out as the chief architect there, so kind of one of the first employees to build a product, and now I'm the vice president of our EDR strategy.
Oh,
So I kind of
nice.
have a whole team that I manage to put new fun stuff in the product to detect more badness. So things like I showed in the presentation today,
Yeah.
you know, it's nice to detect them by hand, but if you can have software that kind of sees someone is using that attack, it's good data to have.
So you bring the voting issue here. What do you think about electronic voting? And as you may know, we recently held a voting panel where they were discussing problems in Brazil, Argentina, and other countries about electronic voting. What do you think about it?
I mean, I think from a point of view of kind of making it easier to vote, it's great, right? And I think the more people can vote, the easier you make it for them to vote, the better it is. But I think anytime we make something too convenient, if you don't take security into account, you've got problems, right? Whether it's automated cars, whether it's voting, of course, voting has such a much bigger impact, right? Because you know, if you make a mistake in your smart fridge, and smart fridges leak some water, okay, you make fun of it, you move on. But usually your fridge is not going to cause like a major political shift in the country, right? If you make a mistake in security for electronic voting, or hospital systems or things like that, that's really critical infrastructure, right? Whether it's kind of human critical infrastructure or physical critical infrastructure, that I think the world is still not mature enough in terms of how they approach security, that things need to be better.
And your findings bring me something to my mind, that when developers here presented the voting systems, they only focused on the problems that they could have on the code that they have right for the voting, but they never talked about all the operative system running behind it and how it can be used to merge or to play with their software.
Yeah, I find that a lot of times when people do security analysis systems, they look, you know, it's kind of like one onion, right? And they look at one layer and they say that layer is safe, and they trust that the layer behind is safe. A lot of times I meet people say, oh, but Alex, the Windows kernel is only like 10 people at Microsoft, right? So there can be no bugs. Okay, but there's also a million drivers around it, right? And then the kernel runs on a hypervisor, and the hypervisor runs on the firmware, and the firmware runs on the CPU microcode, and there's always one more layer that people seem to kind of ignore, right?
Well, here it was the case, and something like that, because the voting machines that are used here in Argentina run over Ubuntu, and the first thought of many people was, well, okay, at least it's Linux,
right?
But the problem is, well, okay, but it's a specific version of Linux that it cannot be patched, because if you patch the
integrity
version, it's not the same integrity that when you are going to vote. So someone has to update the patch, and it's a really complex system. And it's not only the Python application that lets you to select the candidate.
And even the hardware itself, right? Even if the OS is secure, what kind of hardware is it running on? What's the BIOS, the EFI? So. And
there was other issue here that was that they said that the machine, it didn't have any bugs, but when analysts take one of these machines, they found that there was like a mini computer to use the RFID system for the electronic paper, and it was like, okay, but which software is running the computer for the RFID and how it works?
A similar issue we've seen in the US, I forget where it was, these machines that the results are transmitted over Wi-Fi to a central server. And of course the Wi-Fi card had a custom binary blob, and the machine could be 100% secure, but the Wi-Fi firmware itself could be manipulating the votes that were sent. So it never ends, you know, with these guys. So I think it's important to always have like a physical proof, something tamper-proof. I don't know, maybe blockchain will one day solve this, who knows, but
blockchain
a lot of work to do.
Tends to solve all the human problems.
Exactly, yeah, until we find other problems with blockchain itself.
Well, just to finish the talk, you have an impressive background, which is the Windows and managing the kernel and reversing the kernel. So how long have you been doing this?
Well, officially I started around 1999 when I started working on React OS and reverse engineering Windows. But I think my parents would tell you that I've had a passion my whole life. I think, you know, my dad put a password on the computer when I was 4 years old so that I couldn't use it without permission. and I started hitting Control C, and I ended up in like a DOS TSR, and I started typing commands, and so kind of my whole life I wanted to go deeper, go see what's behind the screen, what's behind that. So it's kind of been, you know, kids playing on the street football, I was on the computer trying to do things. So I don't know, I've always had the mind of reverse engineer.
I guess it's a commonplace for a lot of people around here.
Yeah, exactly. Yeah, I feel at home when I'm in places like this. People understand. Yeah.
Well, thanks for everything.
Thank you for having me. I appreciate it. Thanks a lot. Take care.
You too.